All right, we're going to look at lesson 6C, which is the complex fractions. Complex fractions are when you have fractions within fractions, which is just ugly. No math teacher ever wants you to leave an answer like that, so you always have to work them out and simplify them as far as you can. So the way you're going to go about doing that is you're going to put each expression in the factored form if it's not already done for you. That means you might have to find a GCF. You'll factor difference of squares, your sum and difference of cubes. You might be working with trinomials with or without leading coefficients, and you might even have to do some factor by grouping. So all of those methods that we've already gone over are going to come back into play with this chapter. Once you've put everything in factored form, you have to determine what your least common denominator, or your LCD, is. And you're going to use the denominators of every fraction to help determine that. Once you figure out what your LCD is, you would multiply the numerator and the denominator by that, cancel out anything you can, and simplify what's left. So, if we look at this first example down here, what we have is 5, which is factored. X plus 4 is good. 1, and then we're going to pull the 2 out because there's a GCF, and that gives us x plus 4. And then we're going to focus in on our denominators. We have x plus 4 in this one, and 2 times x plus 4 in this one, and come up with our LCD. So between those two, I would say the least common denominator is going to be 2 times x plus 4. Because you want to make sure you include everyone, but you don't have to repeat it. Like, since there's an x plus 4 here, you don't have to write it twice. All right, so we're going to multiply this current fraction by our LCD. And what allows us to do this is you are allowed to multiply, divide an expression by anything you want as long as it is equivalent to 1. Alright, so this x plus 4 is going to cancel out this one. This 2 is going to cancel out this one, and this is going to cancel out that one. So by doing the LCD, what happens is you get rid of the denominator that is within each the numerator and the denominator. So we're left with 5 times 2 on the top, and we're left with 1 on the bottom. So we would say our answer here is 10. All right, let's look at another example, because you know they're going to get a little more difficult than this. All right, so here everything is in factored form, but you got to come up with the LCD. So the LCD between 6, 3, 5, and 10 is 30. So we want to multiply this numerator by our LCD, and we want to multiply this denominator by our LCD. And since those are two terms, we're going to have to distribute. So you have 30 times x over 6 minus 30 times x over 3, and then we're going to have 30 times x over 5 minus 30 times 7 over 10. And what happens is the 6 makes the 30 become a 5, the 3 makes the 30 become a 10, this 5 makes this a 6, and this 10 makes this 30 a 3. So if you'll notice, our denominators are gone, and we have 5x minus 10x, and then we have 6x minus 21. And if you combine your like terms, that's going to leave us with a negative 5x over 6x minus 21, which is a perfectly acceptable answer. Nothing wrong with that. You can also write it as negative 5x. You can factor out a 3, leaving you with 2x minus 21. But if you notice, But doing that factoring did not get me anywhere. Nothing canceled out. So that's why it's okay if you don't do it. So either one of these would be an acceptable answer. All right, let's look at another example. Right here, everything seems to be in factored form. So you have to decide what your LCD is. And in this case, it's going to be x plus 5 times x minus 3. So we're going to multiply that in the numerator and in the denominator. Okay, and so here our x plus 5s are going to cancel out. And we have 3 times x minus 3 on top. On the bottom, you have the 2 over the x minus 3 being multiplied with the x plus 5, x minus 3. And your x minus 3's cancel out. And then you have 1 over x plus 5 being multiplied with the x plus 5, x minus 3 LCD. And our x plus 5's cancel out. So what we're left with now is 3 times x minus 3. And then we have 2 times x plus 5 plus 1 times x minus 3. So we have 3 x minus 3 on top. And then what we have on the bottom is 2x plus 10 plus x minus 3, giving us an answer of 3 times x minus 3 over 3x plus 7. Now this would be the factored form. You could also say 3x minus 9 over 3x plus 7. Again, the factoring doesn't get you anywhere, so it doesn't make a difference whether you do that or not. All right, let's try another one. Okay, first you want to make sure everything is in factored form. And so you can't factor 2x minus 5, but you can factor 8x minus 20. There is a GCF there of 4. If you factor that out, you get the 2x minus 5. And that's why you want to go ahead and factor, is because it helps you pick up on some common factors that might be hiding. All right, so looking at this, our LCD, we need the 4 and we need the 2x minus 5. All right, everybody else is included. So we're going to take our numerator, multiply it by our LCD, take our denominator, multiply it by the same LCD, because remember it has to be equivalent to 1. All right, and the first one, you're just going to be left with the 1 and then the 4, because the 2x minus 5s are going to cancel out. And then on the second part of that, both the 4 and the 2x minus 5 cancel out, so you just have that 7 that was there. And this one, the 2x minus 5s cancel out, so you're left with the 4. And so what we have is negative 3 over 4x. And there's nothing that we can do with that, so we're finished. All right, let's try our last example. Okay, let's look at this one, see if there's anything that can be factored. Now this one's got some GCFs, some difference of squareds, and some trinomials. So if you look at the top and you factor out a 3, that's going to leave you with an x squared minus 1, which factors as x plus 1, x minus 1. So So there was a difference of squares hiding in there. And then we have 5 over x plus 1. And then this trinomial factors as x minus 4 and x plus 1. All right, so if we go and look at our denominators here to come up with our LCD, this is going to be a pretty lengthy LCD, but it is what it is. Our LCD, we need a 3, we need an x plus 1, we need an x minus 1, and we need an x minus 4. So we're going to do that up here. 3, x plus 1, x minus 1, x minus 4. On the bottom we've got, and remember this belongs to the entire denominator here, 3, x plus 1, x minus 1, and x minus 4. Alright, so our 3's are going to cancel out, our x plus 1's are going to cancel out, our x minus 1's are going to cancel out, and that's going to leave us with an x minus 4 in the numerator. Alright, with this first one, when we multiply this 5 over x plus 1 with this 3, x plus 1, x minus 1, x minus 4, the x plus 1's are going to cancel out, and you're going to have 5 times 3 times x minus 1 times x minus 4. And then we have the minus, and you've got the x plus 4. Now the x minus 4's are going to cancel out, the x plus 1's are going to cancel out, so that's going to leave you with a 3 and an x minus 1. So this is x minus 4 here. When you multiply the bottom, you're going to get the 15 x squared minus 5x plus 4 minus 3 times x squared plus 3x minus 4. To clean up that denominator there. And we're going to have x minus 4. Get a little more room here. Alright, so over. Alright, we're going to have 15x squared minus 75x plus 60 minus 3x squared minus 9x plus 12. Alright, so final answer. Finally, see how they can get really long. The 15x squared and the 3x squared gives me the 12x squared. The minus 75x and the minus 9x is going to give me a negative 84x. And the positive 60 with the positive 12 is going to give me a positive 72. So that would be one way you can write the answer. Now there's a denominator there, you can factor that. And if you do, it doesn't, again, nothing cancels out, so if you don't do it, you won't be penalized. The thing is, until you do it, you don't know if it's going to cancel or not, so you kind of need to do it. But the 12 comes out, and it factors as x minus 6, x minus 1. So either one of these are acceptable ways to write your answer, okay? And you get full credit either way. So those are complex fractions. You can see they can go anywhere from easy to hard. The rules don't change no matter how hard the problem is. It just gets to be a little bit tedious. All right, so go ahead and try some practice with this, and we'll see how you do.